Hello engineers and welcome back to the DevSecOps series. So in our previous video, we have learned what is DAST. The theoretical part we have already covered, but for the practical hands-on lab, it is still pending on my end. So I guess we'll cover it really very soon. But for today's topic, we have the term which is called as IAST, the methodology that is pretty widely used these days for testing your application against security measures. So what is IAST? It's interactive application security testing, and what it helps us in doing, what is the basic difference between SAST, DAST, and IAST? Okay, all the ASTs are similar. Okay, it deals with all the application and infrastructure security, but so the difference is what we are going to see, what it does, okay, which are the different tools, and what is the scope of coverage, what are the different types of IST tools. So that is the main point that we will be learning in our today's video. So, sorry for the delay in coming up with this particular topic, but I was a bit occupied with some of the things lately. And if you follow my LinkedIn, you might have known what was that. So do check out uh, uh, the handle that I have on LinkedIn. So let's begin with this thing. What is IST? These are the topics that we are going to cover. Okay, how IST works, different types of IST tools and sensors. What are these things? Okay, what are the features, limitation, vulnerabilities that are detected? So you remember there were certain vulnerabilities that were being detected by SAS tools, by SCA tools, and by DAS tools. But what is difference between all of those things, and what is specific about IST? That is what we will learn about it. Then what are the different popular IST tools, and then the difference that would be majorly asked to you guys if you are going into an interview. So people might ask, okay, yeah, you know SAS, DAST, SCA, but do you know IST? Okay, then if you know IST, what is the difference between SAS, DAST, and when to prefer what? Okay, when to use what in what phase? So that's the basic kind of questions that you might encounter in your interviews. So I don't believe most people delve into this particular topic, but yeah, it is really important for you as a DevSecOps engineer. So, as you have already seen, interactive application security testing, what it does is basically it does the work of both the SAST and DAS. So, basically, it combines the code analysis as well as attack simulation that you are, kind of majorly performing in DAS. So, how does it work? It is basically, it works usually by deploying an agent, okay, within the application server. So it is a part of application server, okay, not the application itself. It's the part of the application server or the runtime environment or the running application. Okay, so you can deploy it in three different levels, as I mentioned: application server, runtime, and the application itself. Did I mention that it was not a part of application? Oh, sorry, my bad on that part. So because there are two aspects. In the next session, we are also going to look at RASP. So RASP is directly injected in an application, okay, which gives you the real-time security or kind of any kind of attacks that are being done on the application. So there is a slight difference between IAST and RASP that we will also look after in the next videos. So for this, it is deployed as an agent. So this is really important stuff that you need to consider. Then what it does is to analyze internal code and behavior in real time by providing accurate, timely, and context-aware vulnerability detection. Okay, then either SAST or DAST. So what it does is, let's say, um, if you are a security agent in a firm, let's say, and yeah, let's say you are driving an aeroplane. Okay, not driving an aeroplane, but flying an aeroplanes for that matter. So, what is beneficial for you? Okay, do you need to be there in the plane to check for any threats? Let's say some people hijack aeroplanes. So, it is important to check the passengers when they are onboarding into the plane. Okay, that is the first step. Then again, when they are onboarded, you need to again check in the insides with any metal detector or anything in the luggage. Is there any weapon? Okay, any kind of gun or rifles inside the luggage of the uh, passengers. So those are the two stuff that we do. Then in the flight, okay, who is going to, like, somehow someone brought in a weapon and then tried to kill the people over there or tried to hijack the aeroplane. So is there anything that we could deploy while the aeroplane is in transit to check for any kind of attacks or security threats over there? So this is where IAST and RAST comes into play. So they work side by side, or they are deployed as an agents in your application or your system to check for such kind of attacks. So that is why these two terms are up, like, apart from the SAST and usual dash that we do. So I hope that example was helpful. But if you are not again more clear of it, we will see it in the next slide as well. And one more thing, the context aware, okay, it knows when what kind of attack is been occurring on your particular application. So let's see how the IST works, so to say, to get more clear understanding on this part. So there are four different ways that the IST works. So instrumentation is the first part, then runtime monitoring, interaction with the application, and then real-time analysis. So what is the general flow of IST applications? So the IST tools deploy agents or sensors. Okay, so they deploy things, either agents or sensors, directly into the running application. And what these agents or sensor do is, these instruments continuously monitor the application from the inside as it executes, observing code behavior and data flow. So now imagine you are into an application and okay, like in Dust, what it did is what was directly attacking the application and looking at the uh, response that it was triggering. But in IST, it also has the access to the code base. So you will also look into the code and the internal logic of this application and know, okay, so this is the way that the code is behaving when I simulate an input or a kind of malicious input or an attack on this particular code of the application. Okay, so it sees the context, it sees the page that you are on, and then tries to attack that particular thing, and then sees how the data flows and what are the responses are coming out, and then analyze and then give you the results. And it would show you exactly, okay, this line of code is behaving in this way, and then when I triggered this kind of input, it give me this kind of response. So that is what IST look after. So that is what we call as runtime monitoring. Then it interacts with the application. Okay, it relies on the user interactions, either through automated test or manual testing, to trigger the code execution and test specific functionalities. So as I mentioned, what it would do is, it would either rely on you or an automated test case suite test case suite to rely on this kind of like, click this button, enter this input, and then click that button, submit this thing. So these are the manual things that you need to do first, or you can automate these things on your own. So you can also try to automate the security or the kind of attacks that are possible on this particular application. So those are the things that you can control. And then once you do this, once you trigger this analysis, when the interaction occurs, the embedded sensors analyze the code in real time and correlating user inputs with the application's internal response as they, and then identify the vulnerabilities as they happen. So this is what generally happens. So you run the application, you deploy the IST tool with it, and then you kind of simulate certain test cases or certain attacks, either manually or in an automated fashion. And then how the application responds to that, that is what basically checked. So it would go for the internal logic as well as the outputs. So remember, the SAST and DAST were looking at it separately. Okay, they were having certain limitations. Now Dast was not able to look at the code base, and it was not going to somehow tell you that this line would give you this particular error, okay, when I tried to simulate this kind of attack. And then in comparison to Dast with SAST, SAST was not having the visibility of the runtime situations or the environment that the application was supposed to run on. And then even if you give any malicious input, it would not kind of give you any uh, feedback on that. It would only just scan your code and let you know if it thinks that it is weak or not. So basically, that's the difference between both of these things. And then IST gaps all the, I mean, IST fills the gap that we have seen over here. So then as the application runs during QA, functional or manual testing or integration or a lot of different testing phases, the agent monitors what? It monitors the source code execution path. Now, there are certain function calls that your application goes through. So one thing will call another thing. I mean, the front end would call an API. API would call a database script, and then database script would again give you an callback function. So those are the things that your source code goes through. I mean, the execution path, so to say. So this is what uh, it could be also called as a reachability analysis in certain cases. So that is how IST would analyze. Okay, once you hit an API, then it goes to there, and then on this line you found this particular vulnerability, or it behaved in certain way. So that is an important insight for us to see how our code functions in the runtime when someone gives you an input. So that visibility is really important for a developer to pinpoint, the flaws in your application. So execution paths, reduces the debugging time that you may require in certain cases. So I hope, and DevOps engineer would not grasp the gravity of this particular feature, but I would make sure, I mean, not I would make sure, developers will really, appreciate this feature, because they do not I mean, they do not have to later on go into debugging mode and then test, okay, this is on the line number 165 that I am facing the issue, and then here it's what I need to, fix the code in that particular fashion. So the source code execution path is really important. Then the data flow, how input moves through the app. Okay, so once you enter your name and then press the submit button, how your data from the front end application is moving till the database. So this is also the one stuff that the agent monitors or look after. So then it would know, okay, on what point I can transform this particular data with any kind of attack. Okay, either by man in the middle attacks maybe. Okay, so that is a part of RASP, not IAST, but you get the point. So configuration and dependencies are also what looked after by the agents. They again show you if this configuration is good for the application, if the performance is good, or if there are any security issues, majorly for security issues. And the dependencies, if they are obsolete or they are any vulnerable components in your dependency charts, either direct dependency or transitive dependency. I hope you remember the dependency scan that we have done using the dependency check tool in SCA. So if you forgot those things, you can always click over here and check for that particular video. Then interaction with APIs, as I mentioned, the libraries and the databases is what you also look after in the IST. So sorry for the bad handwriting today. I am not carrying my mouse together with me. So the reason that you see your squiggling lines over here and there. Apologies for that from my heart, really. Then the next stuff is what are the different types of IAST tools. So remember, uh, uh, okay, I think we have not touched on this topic, but I'll leave it for some other day. Let's see. So types of IST tools and IST sensors. So there are two different topics on this particular front. So let's see the tools first. So there are passive IST tools, there are active IST tools, and then there are true IAST. So what is the difference between all of them? So I'm not sure if an interviewer in your interview would go this deep in the particular topic, but let's see. So uh, passive IST is what most tool provides only a sensor that attaches to the running application. So as I mentioned, it would be deployed as a part of the application or the environment or the application itself. So now somehow there are certain IST providers that would only give you an agent or sensor that would attach with the application when it is in running state on its environment. So now if this sensor notices something suspicious as the application is running, okay, it reports to the IST solutions dashboard. So now someone tried to attack you, or while executing a certain input, it found out, okay, this is breaking the solution in this way when I try to input it in this fashion. Now this is captured, and then it is sent as an alert or as a report to the dashboard that your vendor has. Okay, so you detect something, I mean, first you throw any input to the application, then it detects a particular suspicious returns or activity or anomalies in the application. Then it saves this thing, logs it into this file system, and then it reports back to the dashboard that you have, so that you can see it. It should not be there only in the logs, it should be visible to you as a developer or security engineer. So those kind of tools are usually induced by QA or unit test and cover only the code that is included in QA testing. So I hope you remember the different phases of testing. Okay, so unit test, integration test, then regression, and all the smoke test, other stuff. So here you would only go by the unit tests that are provided for each uh, component or each function or whatever you say. So until and unless there is a code coverage for the entire code base, you might have certain difficulties in finding out, okay, I have left something to be tested. That's one thing to be taken care of in terms of passive IST. When comes the active IST, so a large selection of IST tools on the market are delivered by DAST makers. Okay, so as I mentioned, not just code, but it would also try to simulate attack and then check the responses. So that's where the DAST comes. As I mentioned, the DAST and SAST are combined in it. So, but not as an integrated product. Okay, so often it is called as induced IST. So it is not part of this particular uh, application, but it is deployed, and it is separate from that particular environment entirely. So that's the reason it is called as DAST induced uh, IAST. So then these uses DAST to activate IAST sensors, but do not collect data from two sources. Then they work just as if you took a passive IST solution and combine it with the complete separate DAST. So what do we mean over here is that DAST would trigger certain attacks that would activate your IAST sensor. So imagine uh, I, as a red teamer, if you know this concept, okay, is there on the plane. Remember the example of plane that we were talking about earlier. So now you do not know, I mean, you, the security engineer, do not know that I am a part of the same team that you are on. But now I am only trying to pretend that I am a attacker, and I want to see how you react to that particular thing. Now I would stand up, pull a trigger on the messenger, and now how is your response? That is what I would trigger. I mean, I would want to check. These are the dashed. It would simulate an attack to activate the IAST sensor. That is what we mean by that particular thing. So now I, as a dash tool, would not take any data from you. Okay, I would just trigger certain attacks. Now you have the responsibility of storing the data of how this attacks started, and then what happened after the attack, and how you responded, and how your application responded in that certain case. So you have the responsibility to collect this particular data, and then you would provide it again. In the case of passive IST, how we did is to report it to the dashboard. So that's why here it is mentioned that they work just as if you took a passive IST solution and combine with it a complete separate dash. That is what it means over here. So then uh, comes the true IST. So a handful of tools on the market go step further than active IST, and these have been dubbed as true IST. That is what they mean to say. So this is because for these tools there are actual interaction between the inducing element, a DAST scanner, and the IST sensor. Now, what do I mean by true IST? I am an attacker. You are a defender. You are a security personnel. Now, I will tell you how did I enter your system and how did I attack on the specific page of your application. And then you would register that particular information, and then you would store it. Okay, okay, so this is the way he can penetrate through the system, and then okay, this is how he kind of attack me. That information I will give you, then you will store it in your certain system, and then you will uh, you know work cooperatively with the DAST scanners as well as the IST sensors, and then you would uh, give that particular response. So, okay, I attacked, I give you the information. You kind of looked into the behavior of application, and then you found out the source code mapping. And then you combine both of this information, and then dumped it to your solution. So that's what these to communicate uh, and influence each other, and then provide better results, the dash scanner as well as the IST sensors, and then attain a very low false positive rate. So if you remember false positive, false negative, I hope you know it by now. So then fully confirm the security vulnerabilities. All the dashed and IST results are also collated into common reporting interface. As I mentioned, it would take both of these things and then report it somewhere in the dashboard. So there are these Invicti and Acunetics kind of tools that you could consider as true IST workers in the market. So next is, I hope you got the point of true, active, and passive scanners. Okay, that is really helpful for you to determine which type of IST tool you need to go for. Okay, either you only require a passive scanner, or you need an active tool, or you need a true IST tool. So then, different types of sensor. So all IST tools need sensors to monitor the running application. There are few different ways to implementing them. So there are these two ways. So invasive sensors, non-invasive sensors. So if you go by the name, passive IST tools work on the basis of invasive sensors. So as I mentioned, it means that for the IST tool to work, the developer must introduce changes to the source code. Okay, this is called as instrumentation. So sometimes passive IST tools need to be a part of yours. I mean, there must be certain calls that you need to go for the particular sensor, and then these changes would be, I mean, these sensors would only detect if you have certain inputs in your code base, and then they know where to throw these results to. That's why you need to, attach your application with these particular invasive sensors. So as you know, like this mic might be attached using a USB. So if I don't, I have this mic, I have electricity in certain different manners, but if I don't plug it into the laptop, it will not receive the communication that I do with this to my laptop. So that's, you can consider as an invasive application, that it needs to be attached in the source code. Okay, not in the source code exactly, but it is attached to the USB port. But then there are certain drivers that behind it, where the source code actually is to, map the input of this particular tool or device. Sorry. And then non-invasive sensors. This kind of sensors are not placed in the source code. Okay, and don't need any code modification. Instead, the sensor are attached directly to the server side runtime environment and then listen in on the code. as it executes by the web server or application. Okay, so as I mentioned, certain wireless devices, they don't need to be directly attached to your application. You can directly, attach them in a, or deploy them in a certain environment, and they would outrightly uh, see whatever the code that is there in your application. Let's say, as an example of a wireless adapter or wireless Wi-Fi connection. So you have them in a particular environment. You have your laptop or your mobile phone in a certain range that it would work together, and then you just turn on the Wi-Fi in your the wireless receiver in your laptop maybe, or your mobile phone, and then it would receive the waves of this particular emitter. So that's a kind of non-invasive sensor. So you do not attach it directly to your application or your mobile phone, but it still works and it listens on. So that is a kind of non-invasive sensor in terms of IAST. So then tools that use non-invasive sensors are able to scan application without any changes to the source code or configuration. It is given. So now let's talk about what are the different features of these IAST. Then we will go into what are the differences. I mean, what are the limitations, and then the differences of IAST versus DAST versus SAST. So, feature, it would give you real time analysis. So it would find vulnerabilities as the app executes. So I guess that is pretty much given or understood by the time of that we have this discussion. Then the accuracy is high because it reduces false positive, because it is there with your application in the environment when it is running. So that's why, okay, how this attack would arise, or how certain inputs would behave, or how the application would behave when we give certain kind of inputs. Then broad coverage, so detect issues both on the code and the runtime environment, as we already discussed. SAST would only look for code, DAST would only look for runtime environment and the application execution, but here we have both of them. Then we have context rich result, as you can pinpoint exact lines of code and execution flow, causing the security flaws. So, uh, as I earlier mentioned you that you know you would developer would really need a less time to debug this particular solution, and then he would exactly know where to change the code to avoid this kind of breaking of the application. Then continuous testing, it could be triggered on all the QA test or the DevOps pipelines that you might have. So that's why it would test your application in a constant way if it is a part of your CI/CD pipelines. So then you have limitations of this IST. So it would require runtime dependency. So requires a running application, making it unsuitable for very early development stages when code may not be executable. So it is really for a mature application. It would not be helpful if you directly integrate it when you are kind of starting the development of your application. But it would be really helpful when your application has a bulky amount of functionality and has multiple pages. That's when it would give you more value rather than adopting this IST in early stage. So that's why when we are in the early stages of development, we only go for SAST and SCA. BAST also again comes after your application is in a form of running state. So those are the two differences that you have to uh, think of when adopting this particular thing. Then limited core coverage. So only tests the part of the application that are actively executed by functional tests. So remember I mentioned earlier that it would not cover entirely the application unless you have covered entire unit test for all the functional application code that is present in the software that you have created. So it would be limited as much as you give it. It would not cover the entire application. So that's one more limitation. So you have to be actively working on the unit test cases. Then complexity. So deployment and integration can be more complex than SAST or DAS tools. So somehow, As you go for more context aware application, the complexities grows over time, because you have to do a lot of integration between the application, the sensors, the dashboards, and all of these different things. So that gives you this particular complexity. Then next is what vulnerabilities that are detected by IAST. So you can go through this particular list. We will not delve more. So remote code execution, OS command injection, server side request forgery, as it is a part of your application. So server side requests could be also tampered. So it would also check for that. So remember, this was not a part of DAST. So to say, it would only give you that okay, SSRF is possible. But how is it possible? On what line of code is possible? It would be pinpointing this to the dashboards that we have. Then SQL injections, local file inclusions, okay, remote file inclusions. Can it be done? Can we do a directory traversal on the environment? Cross-site scripting is possible on the UI or not? Then injections, kind of external entities can be possible or not. Okay, the injections, XML external entities. Then command sorry, carriage return and line feed, is it possible? CRLF. Then email injection can be done, or HTML injection could be done, NoSQL or JSON injection. So these are the different types of attacks. You can find out about them. Okay, what is IDOR, insecure direct object references? What are these buffer overflows, integer overflow? You can find it out about how these particular vulnerabilities behave, or how it could occur, and what damage it could cause in your application. So I think we have done a lot of different lists of vulnerabilities in our past videos in SAST, SCA, DAST, and now IAST. So you should be pretty familiar with this kind of vulnerabilities, and we have also learned it in the CVE in the CVE part. So you can find out about this vulnerability, so that you could answer it in your interviews whenever certain person asks you, okay, can you tell me certain different kind of attacks that are possible on your application? And then you can say, okay, yeah, I know 10 or 15 of these things, and these are the ones. Then next is different popular IST tools. So Contrast, Invicti, that we have learned earlier, Checkmarks IST, Black Duck Seeker is an IST, then HCL AppScan on cloud. So these are the different, you know, what we say, the tools in the market. Then lastly, we come to the IST versus SAST versus DAST versus SCA. So we already did it in your previous video for SAST, SCA, and DAST, but now we'll learn into what is IAST. So then, analyzes running application. Okay, IST does it, DAST does it, SAST and SCA, no. Access to the source code required. Yes, IST requires it. SAST requires it. DAST doesn't require the access to the source code and SCM. Then language dependent. Yes, Java application would have different kind of test cases as compared to C#.NET, as compared to Python, as compared to JavaScript and Angular application. So it is heavily dependent on language. What kind of language coverage is done by the application? I mean the IST tool. If it doesn't support Rust, you cannot test your application for IAST. If it doesn't support Python, you need to look after another solution then. So that's why it is heavily dependent on language, as the rules for the SAST are dependent on language specific stuff. Then SAST is also one more stuff in language dependency, because SAST would cover a lot of different languages. So we can combine IST and SAST for these results. Okay, then DAST and SCA do not care about what language you use. Then does it find real world exploits? IST would certainly give you. SAST would not give you outrightly, but it would show only weaknesses in the code. DAST would give you real world exploit by DAST do not have the visibility to the source code. IST does have this. So what DAST would do is DAST would simulate attack like an attacker, a real attacker who do not have any visibility in your application. And then it will show you, okay, this is how I exploited your application. But where did I exploit it? How did I exploit it? I do not know in your application what are the mistakes in your application that triggered this particular response. So I will only attack and let you know, okay, is this exploitable or not? But how is it exploitable? Where did it occur? It would be shown you by the IAST solutions. So the tools, Contrast, Invicti, SonarCube for SAST, Zap and Burp for this thing, SCS, Sneak, BlackTurk and all these other stuff that you can see in the market. So um that's about it. We'll move to the last slide we have for IST. So we have covered a lot of topics out of this thing. So threat modeling we have done SAST, SCA, and we have done DAST. Now we are here in the IST. Next is what we're going to see is RASP and MAST. So other things we would again see as the list grows in our the first video that we have seen. So that's how it is, and I guess uh, we have pretty much covered a lot of different topics: SAST, SCA, DAST, and now IAST. We will be covering a lot in our future videos. Sorry for the delays in this putting up of this information. Uh, and So that's all for IST. Let me know if you have any questions, thoughts, comments in the section below, and I'll also provide you with the links to the PPT in the description. You can find it on my GitHub repository. That's all for now. See you again in our next video. Until then, keep learning. Bye, guys.